So again, the key point of the VPN v4 update here is that the next hop value of 11.11.11.11 points us towards the IGP plus BGP transport label that we use to tunnel the traffic over the core. Now, once we get to the egress PE, which is XR1 in this case, they have removed the top label and they see label 16,017. From XR1's point of view, if we show MPLS forwarding table and look for 16,017, this should be going as an unlabeled packet out to the VPN customer. Now in this case, it is okay to see unlabeled because this is going towards a native IP interface. It's not going to the MPLS core, it's going towards the layer 3 VPN edge. And notice here that we're generating a VPN label for each of these customer learned routes. That for 8888, we advertised 16,016. For 4444, we advertised 16,013. And if we look at where is 4444 supposed to go, this is going to router 4. Let's say that we look at routing to this from 7's point of view. So from router 7, we trace to 4444, source this from our loopback. It's going from 3 to 12, so 3 to 12 to 11 to 4. When the packet is transiting over XR2, who again is not running BGP, is only running IGP plus LDP, the packet arrives with a 2-label stack that is 16,010 and 16,013. If we go to XR2 and show MPLS forwarding table, notice that we don't know what does label 16,013 mean. Okay, our label space is ending at 16,010. The only one that we care about here is what is 16,010, which this should say that this is going to the loopback of XR1, or in other words, that is the egress PE for that particular MPLS tunnel. So going back to the overall portions of this again, the key is that the BGP next hop points to the PE's loopback, and the PE's loopback is reachable via an LSP that we had already pre-established. Now, whether that LSP comes from LDP, comes from BGP plus label, comes from RCPTE, it doesn't matter. Because from the data plane point of view, the label formats are equal. The only difference is how were they originated in the control plane. And we'll see another example of that later in layer 2 VPNs is when we look at a VPLS label that was bound through LDP versus a VPLS label that was bound through BGP. We have two separate signaling protocols, but from the data plane point of view, they're identical. That in the MPLS core, the only thing that we care about is that we're looking at this topmost label number to figure out what is the egress PE out of the network. Once the label traffic gets to the final PE, they see the one label stack, and they're going to be making a decision on the inner label. So if we were to look at this from our packet capture point of view, let's say that we're going to do a ping that's going from router 7 to router 4. Okay, also let's say that this is going through a couple different devices. So let's say from router 3's point of view, we're going to shut this interface down. We're going to force the traffic to go this way first. So it's going to go up to XR3, then over before it goes to the final destination. So from router 3, let's say that on interface gig1.313, that's going to be shut down. And then from router 7, we're going to ping 4444, sourced from 7777, and we'll just send one packet. From our capture point of view, let's look at just ICMP. Okay, we see that there were 4 hops along the path. So we have the first hop is the one with the packets coming in from router 7. So we have one hop here, second hop's going that way, third hop is to XR2, fourth hop is to XR1, and then the fifth hop is going to be to the final destination. So let's see, in the capture we see 1, 2, 3, 4. And let me trace that to make sure it actually went that way. .312, no, I shut down the wrong interface. I should have shut down. I should have shut down 312. Okay, so now we should go 3, 13, 12, 11, 4. And it's going to take them a minute to reestablish LDP and IGP will be the issue. Okay, so in the meantime, let's ping. And if we show MPLS LDP neighbors, we have the adjacency to 14 or to 13. There we go. Okay, so let's redo the capture and we'll do just one packet. We ping, repeat count is 1. Okay, so we should see 5 packets now. Okay, the first one along the path is coming in as native IP. So we should see that this is just a regular ICMP. We see it's Ethernet, IP, and then ICMP. Okay, it now goes to router 3. Router 3 is going to do the imposition. Or in other words, it's going to do the push operation. So it's taking the IP packet in, and it's going to put it inside of 2 different MPLS headers. The top one should be talking about the loopback of XR1, or in other words, the transport label. The bottom one should be talking about the final destination 4444, or the VPN label that was originated by XR1. So if we open up the second packet, we should see 2 labels in the stack. We see Ethernet, then MPLS, MPLS, IP, and then the ping. If we look at specifically in the MPLS headers, these have labels 16,012 and 16,013. Notice in the second label, it is set the bottom of the stack to 1. Or in other words, saying true that this is the last label that is in the actual packet. The payload is beyond this. Okay, all of the labels above that are going to have the bottom of stack set to 0, saying no, there are more MPLS labels beyond me. So specifically that was 16,012 and then 13. Okay, so 16013, 16012. Okay, this goes up to XR3, and on XR3, what decision should it be making? Is it going to look at the 12 label or the 13? Now, from XR3's point of view, it doesn't actually know this route, correct? So when we go to XR3 and we look at the show BGP VPN v4 unicast, pipe include 7777, we don't have this route. Okay, or likewise, if we include 4444. Because XR3 is not participating in that VRF. It is receiving the route in from the reflectors, but it is deleting it because it doesn't have a route target that matches the local policy. So when the packet comes in, it needs to be making a decision based on the topmost transport label, or in other words, 16,012. So when we show MPLS forwarding table, and we find 16,012, it says it's really going to the loopback of 11, you should swap it to 16,010. This now means that the next packet should go from XR3 to XR2 with label 16,010, and the underlying VPN label 16,013 gets unmodified. So that should be our third packet in the capture. We have 16,010, 16,013 at the bottom. XR2 is going to get it and say, well, what do I do with 16,010? 16,010 should be pointing towards the loopback of 11. It says 11 is directly connected to me, so I'm going to perform that penultimate hop popping, the PHP process, and I'm going to remove one label from the stack. So that one label specifically is we're deleting 16,010, but we're leaving the inner label. We're leaving 16,013. This now means that the fourth packet in the capture, we should see it has now only a one label stack, and the one label should be just 16,013. XR1 says, I actually know this label because I'm the one who originated it. In BGP VPN v4, when I exported 4444 from the VRF out to BGP, we're generating the VPN v4 update, and we're setting the specific label number. So if we show BGP, VPN v4 unicast for VRF A, and the prefix is 4444/32, it should say that BGP v4, that should be on XR1. It says this is a what am I looking for here? I am looking for the where does it show the label here? There it is, local label. Local label is 16,013. So XR1 is the one who is creating this label number as it's advertised out to the VPN v4 network. It means that in the data plane, I'm listening for this label number to come in. When label 16013 comes in, we show MPLS forwarding table, and then it says, well, I know where this is going. This is going to the final destination 4444/32. It's an unlabeled packet. It's going to be removed from all MPLS encapsulation, and we're going to forward it out this interface towards this particular next hop. So this means that the very last packet in the capture, which is number 5, should be a native IP packet going to the final destination. So again, this is Ethernet, then IP, and then the actual ping. Now the reverse is also going to be true when XR1 receives the echo reply back in. It's going to say, look at the final destination and figure out what's the VPN label that I'm using. So on XR1, if we say the final destination is show BGP VPN v4 unicast for VRF A, and the destination is 7777/32, says the local label that I received from my neighbor was 29. The next hop is 3333. So we show MPLS forwarding table, and we look at how do we get to 3333. It says use label either 17 or 16,001, depending on what interface that you're actually routing out. Because in this case, there's equal cost multipath in order to reach that particular destination. It says you can go out 1112. So we could go this way, or it says you could go out 1111. You could go out this way, and then from there, we can go this direction, basically multiple ways. So it really depends on what is the IGP route. If we show route IPv4 for 3333/32, and it says I have ECMP. It's 3 hops regardless of which way that I go. So if we were to trace 3333 sourced from 11, 11, 11, 11, sometimes the packets are going to go to 12. Sometimes the packets are going to go to 1. It just depends on, again, what is the input to the ECMP hash. So the source is different, the destination is the same, but we're making a different decision because the inputs are different. Okay, if the source and destination were the same, but we were to vary the UDP ports on the trace route, we should see that it's still going to choose different values between this. So if we said trace from our loopback, and let's say that the port number is 10,000, that goes to 12. If we say the port number is 22222, eventually we'll see that this is going to start to hash back and forth. And you'd have to give it a lot of different variations in order to see this over longer term. But eventually it's going to choose one difference here based on the port numbers. Okay, so this means that when we look at the returned packet, it really depends which way that it went, if it went through 12 or if it went through 1. But from at least we know that one of the labels in the first hop path should be either 17 or 16,001. So when we look at the first hop in the capture of the return, which is this one here, this is going to be just the ping that's coming back from 4. The next one is going to be the 2-label encapsulated stack that came from XR1, and in this case it happened to be going towards XR2, which is using 16,001. But again, the inner label, when we look at the show BGP for the particular prefix, the inner label is based on the received label number 29. That's the one that router 3 was allocating when it originated the VPN v4 route. Now we'll see that ultimately this type of traffic flow logic is going to be the same regardless of whether we're doing intra-AS L3VPN, inter-AS option A, B, and C for both layer 3 VPN and layer 2 VPN. And you need to be able to visualize how do all these pieces connect together, because when there's a problem in the network, you need to know what's the exact step-by-step process I need to go through in order to try to track these problems down. So in our later sections, we'll take this example and break some of the things that could go wrong in the network. So break issues in things in the core, break issues in the customer network, and see how do we know that this is a problem with layer 2 or IGP versus LDP versus BGP versus the customer side. And we'll see exactly how do we track this on a step-by-step basis from the customer all the way to the final destination. Okay, there were some other issues here that we didn't address that we will talk about later when we look at more details with the PE to CE routing. One was that, as someone mentioned, I thought the BGP AS override would be required in the case I introduced today. Why are the updates accepted by the remote peers, which the same AS should appear in the AS path? In this case, I didn't configure AS override, and the end result is that router 5 and router 4 don't have routes to each other, or that router 8 and XR4 don't have routes to each other, because you're correct. Since they're using the same AS number, I have AS number 456 that is here and here. When the update comes in this direction and goes over BGP, the AS path is going to say 1456, and that's going to cause router 5 to drop the update. So we would either need to do AS override from the PE out to the CE, or the CE could do allow AS in. And then same is true with AS 8914. Router 8 and XR4, those are going to be dropping the updates as they come inbound. There's a question, since the VPN label is data-driven, does that imply that if my customers have very large tables, it doesn't scale? There is a solution for that, though. So if the customer has lots of routes that they're advertising to the provider network, you can simply change the label allocation mode, so you're using one label per customer as opposed to one label per route. And we'll look at that in more details later in terms of customizing L3VPN, but that would be one of the common solutions, that if the customer wants to advertise lots of routes and you don't want to have to maintain separate hardware entries for the LDP labels, then you could just allocate one label per CE or one label per VRF. There's another question here in terms of the relationship between 6PE and 6VPE versus VPN v6. 6VPE means VPN v6. 6PE means IPv6 unicast plus label. So we will talk about that in more detail later. In the meantime, if you kind of want to get a head start on that, there is there's a section in the documentation that I would recommend to read through, which is IPv6 over MPLS, 6PE, and 6VPE. I'll go ahead and post the link here in the Q&A box. But there is going to be a key difference between them, is that they are different address families. That 6PE is IPv6 unicast plus label, where 6VPE is VPN version 6. And it's a difference in the encoding of the update and what that means in terms of the global routing versus the VRF aware routing.